Hi guys, in this video we will be looking at quadratic sequencing. Well, if you're in grade 11 or even if you're not in grade 11, you'll benefit a lot in this video since we are looking at one of the famous sequences, which is the quadratic sequencing. Well guys, quadratic sequencing, it's known by its special two differences, which is the first difference and the second difference, right? Unlike other sequences, but just like other sequences, it also has its own first term. Remember, those differences are denoted by their spatial expression. For example, for a first difference, it is denoted by 3a plus b, and for the second difference, it's denoted by its spatial expression, which is 2a. For the first term, it is denoted by a plus b plus c. So we will use those expressions in our video to solve questions, guys. They will be very, very, very helpful in this sequencing. I hope we will benefit, right? Well, if you're new to this channel, what are you waiting for? Do the right thing. Subscribe to the Innovative Minds tutor. By doing so, you are growing the community. Remember, you only subscribe once. It's free of charge. Without wasting time, let's get to today's video. So we have a quadratic sequencing. The first question requires us to show that it is a quadratic sequence, and we're given 6, 17, 34, and 57. Well guys, to make my life easy, I'll have to write this this expression first here, right? I will have to, so we have 6, 17, 34, 57. So I will say 17 minus 6, what is that? That's 11. Remember term 2 minus term 1, term 3 minus term 2. So what is 34 minus 17? That will be 17. So we go to the side again. What is remember, that's 34 minus 17, which is 17. 17 minus 6, which is 11. 57 minus 34, that will be 23. So we need to show that this is our first difference. So we need to find the second difference now. What is 11 minus, what is 17 minus 11? That will be 6. What is 23 minus 17? That will be 6 as well. So all we can see, guys, this is a quadratic sequence because it has two differences, right? The first difference, this is the second difference, which is denoted by 2a, and this is the first difference, which is denoted by 3a plus b. Then we also have the first term, which is 6 there, a plus b plus c. I hope you can see that. So we have shown that this is a quadratic sequencing. So what is next? Write down the next two terms of the number patterns. Write down the next two terms of the number patterns. So to write down the next two terms, let's continue from here. So remember, if you add, for us to get the next consecutive term, if I say 11 plus 6, I get 17. 17 plus 6, I get 23. 23 plus 6, I get 29. So I'll put 29 there. So what is 29 minus 23? That will be 6, right? Similarly, we need to find another. 29 plus 6, that will be 35. So 35 minus 29, that will be 6, right? So we then ask ourselves how we can get the next consecutive term. Remember, 6 plus 11 gives you 17. 17 plus 17 gives you 34. 34 plus 23 gives you 57. And 57 plus 29 gives you what? Let's calculate. That will be 86. That will be 86. So what about 35 plus 86? So remember, 35 plus 86, that will be 121. So these are the next consecutive terms. So now write down the next two terms of the number patterns. The next two terms of the number patterns will be 86, 121. These are the next two terms. I hope, guys, you are getting it, right? I hope we are learning. I hope we are learning in this video. So, all right. So we go to number C. Go to C, actually. C, hence determine the n term as well as the 100 term. Well, I won't rush, guys, so I'll take my time so that you understand. It is essential that before you attempt any question, pause the video, do it yourself, and recheck yourself. In that manner, you will be learning, right? It's listening and learning. Yes, listening and writing at the same time. It helps you to know that thing, right? So our third question requires us to determine the n term as well as the 100 term. The n term, guys, we're talking about the general term of a quadratic sequence. We are talking about the general term of a quadratic sequence. So using the existing pattern that we have there, remember you have 6, 17, 34. Yes, that's what we have, right? So we have 6, 17, 34. We need to solve this. So I'll take my time without rushing because I don't want to crash. Remember, guys, it's essential that you take your time, right? So that you don't crash, right? So just as I've told you, we have 6, 17, 34, right? As well as 57. So we are going to say 17 minus 6, it's 11, and we have 17 here. We also have 23. Difference is 6. Second difference, this is 2a, 3a plus b, and this is a plus b plus c. So from here, we are going to say 2a. 2a is equals to 6. Then divide by 2 both sides, you got 3. So we have 3a plus b. Where there is a, you replace it by 3 plus b, which is equals to 11. Then 3 times 3 will give you 9. So if you take 9 to the other side, we have 11 minus 9. What is that? That's 2. So from there, we're going to use the first term, a plus b plus c, right? So that's how it should be. So a plus b plus c, right? So what is our first term? Our first term, then we was told that it's 6, right? Our first term is 6, so you put 6 here. So a will be 3 plus 2 plus c, which is equals to 6. Remember, 3 plus 2 is 5. If we take 5 to the other side, 6 minus 5, that will be 1. So I'm having what, guys, here? I'm having three variables, which is a is equals to 3, b which is equals to 2, c which is equals to 1, right? So we also need to find the n term. So to find the n term, let me just get a clean page there so that you can get it. Remember, I'm still working with number C. So what I can do there, remember you have a is equals to 3 and b is equals to 2 and c is equals to 1. So you're going to use the general term of a quadratic, which is an squared plus bn plus c. So we have tn. Our a it's 3, so it's going to be 3n squared plus 2n plus 1. Remember, they said we need to find the 100 term as well. So where there is n, you put 100. So we put 100. Sorry for the background noise. So, okay, put 100 there, plus 1, punch our calculator. If we punch our calculator, we are going to have 30,201. So that's how it should be with number C. Remember, it says hence determine the n term as well as the 100 term. So we have already done that. Hope you saw it. So let's move to our last question. Determine which term is equals to 162. So using the formula that we have derived, guys, right? 3n squared plus 2n plus 1 is equals to 162. So what we could do, it's 3n squared plus 2n. Let's take 162 to the other side. It will be 1 minus 162, which will be 161. It's equals to 0. So from there, I will need to factorize. Factors of 3n squared, it's 3n and n. What about the factors of 161? That will be 23 times 7, which will give us 61. So we have 23 and 7 here. So be very mindful of your sign. This will take a positive number and this will take a negative number. So when you solve this, we're going to have n is equals to negative 23 divided by 3. So we can't have a negative part in here. So what we're going to do is to say NA, this doesn't exist, not applicable. So we are left with what? N minus 7, which is equals to 0. So the aim is to take this negative 7 to the other side, so it becomes positive 7. So definitely T7 is the term that is equals to 162. T7 is the term that is equals to 162, right? You can also prove it here as well. You can see that the term that follows 121 will be 162. Hope, guys, you did understand that a quadratic sequence consists of what? It consists of the first difference and the second difference with their spatial expression. If you are new to this channel, what are you waiting for? Kindly subscribe. See you on the next one.